Here we have seen the Lagrange's interpolation. So how to find out those values you must study. Um, then we have seen the inverse interpolation. So what is the inverse interpolation? Simply if your values of x, instead of finding the values of y, we are going to find out the values of x. Okay. That means here you can see if you are provided with values of uh, that is values of y are given, then you can find out corresponding value of x, that is at which value of x value of y will be 7. So this also we have already studied. Now next we have studied is a forward difference operator. What is a forward difference operator? We are provided with a set of n plus 1 values, and then corresponding we can find out del y naught, that is y1 minus y naught, x is del yn is y2 minus y1, and so on. Similarly you can find out you can see here we are provided with n plus 1 values. Now for the first divided difference we are putting only uh, n values, that is initially we, with 1 2 up to so on n minus 1 in this zeroth one. So totally in the forward difference 1 we will get only n minus 1 n values, and in the second forward difference we will get a n minus 1 values. Okay, and these are the general formula how to write down the first forward difference, second forward difference, and third forward difference. Right. So here you can see the table we can prepare. If suppose we are having totally 7 values, so sixth divided difference will be existing, but seventh divided difference will be 0. Okay. Similarly, the next is backward divided difference. What is backward divided difference? So whatever the values of y1 minus y0, same we are writing, but what is the difference? We'll name it as, instead of naming it as delta y0, that is forward difference operator y0, we'll name it as in the backward difference operator y1. Here also, instead of having y0, y1 up to yn minus 1, we will have the values y1, y2 up to yn. So here also, initially we have n plus 1 values, and in the first backward difference, we will get n values. Similarly, for the second backward difference, third backward difference, and these are the table. Next is the central difference operator. In the central difference operator, what we have to do is small delta y half is we are writing it as y1 minus y naught. So what is the formula for this? In general, we can write it as delta yn minus half is yn minus yn minus half. So this is a what our table. Okay, so next we can have the relation between those symbolic relation between the delta wire, that is delta wire will be wire plus 1 minus wire. L wire is wire minus 1. That is we have to find out the backward difference, that is from the previous value, from the next value we have to subtract the previous one. Okay, so this is what a formula for the central difference operator, wire plus half minus wire minus half. Similarly, we can have a formula that is averaging operator is 1 by 2 wire plus half plus wire minus half. Okay, as you are a student of statistics, you can understand what is averaging operator. Next is a shift operator we have seen, and these are the what properties of the those operator, how the relation works, and these are will be the question for the 2 or 3 marks. You must study those, and these are the things we already studied. Now next is a Newton's forward difference and Newton's backward difference interpolation formula. In the forward we have written this general formula with the help of x minus x naught, x minus x naught, x minus x1, and so on. Instead of writing x naught in the backward, we have written xn, xn minus 1, and so on. And just here you have to find out the values of a naught, a1, and so on. Then you can get the general interpolation formula. Then substitute x minus x naught divided by h will be p, and you will get a polynomial in terms of p. And this is Newton's backward interpolation formula, as I have told, where you have to write down a naught plus a1 x minus xn, and so on. So here you can see this will be nth degree polynomial because we have started with x1 up to xn. That is, we will get the if you calculate this, it will be coefficient of an will be nth power. Okay. So here also we have to find out the values of a naught, a1, and so on. And then after putting, we will get the formula for backward difference operator, forward difference operator. These are the examples that I have already told you. Now next is a divided difference that we have just now seen what is a divided difference. So what is a divided difference we have seen is we have to first find out y of xi, that is y of xi plus 1 minus y of xi divided by xi plus 1 minus xi. Up to now we are only concentrating on the values of y, but here we have to divide by xi plus 1 minus xi corresponding values of x. Then whatever the resultant we are getting, that is called a divided difference. Okay. Now let us see what we are going to see in the next chapter, that is our third unit, that is based on our numerical integration and trapezoidal rule, Simpson 1/3 3/8 rule, numerical integration and the solution of ordinary differential equation. In the numerical integration, we will see what is trapezoidal rule, what is in Simpson 1/3 rule, what is Simpson 3/8 rule, and in the ordinary solution of ordinary differential equation, we will see what is um, Euler's method, what is Euler's modified method. Now everyone know about integration. As I think you have studied in 11th or 10th standard, 11th and 12th standard, what is integration? In general, we can say integration is nothing but the finding the area under the curve. Rather, if you have introduced with the concept of the Riemann integration, why the Riemann integration had been introduced? Already we are having the concept of integration, but we have introduced this Riemann integration because we don't know how to find out the area of a arbitrary shape of a surface. For that, we are going to divide that arbitrary shape of a surface in the form of a rectangle, and then we will find out the areas of all those rectangle, and then adding all those area will give you the area of that arbitrary shape of a uh, equation. Now here also we can see, if you want to find out the area of the curve y is equal to sin x under the 0 to 3 pi, say 0 to 4 pi. You can calculate geometrically also. First draw the sine curve, then find the area under those with the help of area under those 0 to 4 pi, 0 to 2 pi. Okay. So this is called a finite integration and infinite integration. That means if the limits of integration are not given, then this is not a finite integration. So here, in this case, we are going to use Newton forward difference interpolation formula so that we can get any general formula for integration. Then we will see the cases in which we will see trapezoidal rule, Simpson 1/3 rule. In the trapezoidal rule, we will see why it is called trapezoidal rule, what is the geometry behind the trapezoidal rule, how you are going to get a area under the given curve, why it is called a trapezoidal rule, what is Simpson 1/3 rule, and how you are going to apply the geometry behind the Simpson 1/3 rule, that we will see in the next lecture. And in the last point is our Simpson, after Simpson 3/8 rule, we will see Euler's method, that is you have to solve the differential equation with the help of a given condition, that is if your initial values are provided. Okay. Similarly, we can go for Euler's modified method. Okay. And these are the things we are going to study in the third chapter.